Good evening, everyone. Welcome to the opening day reception. This is Subi Kengeri from Applied Materials. We have had the honor of sponsoring the opening day reception today. We are very honored to have that. I'll also take this opportunity just to give a quick overview of Applied Materials and what we do and why we are here. Are we all ready for that? So, very briefly, of course, I have to show this slide. It's a legal requirement. So, very quickly, Applied Materials is the world's #1 equipment manufacturer. We are about $26 billion of revenue last year. But the point to note is that we spend about 10% of our revenue on R&D, and we have to stay ahead of the semiconductor industry because we have to enable the semiconductor technology at any given time. So we do spend a lot of R&D dollars in terms of the pathfinding and feasibility and exploration. So when it comes to looking at the Moore's Law, we all know Moore's Law has kind of slowed down, and which is why we are all here today, which is everything about the chiplets and the heterogeneous integration to continue to scale. But one thing to understand is when the monolithic era, well, we're still in that now, but when it was there and when it came into existence, a lot of things have happened to perfect those monolithic designs. You know, it was almost about 3,000 steps on the monolithic design to make a single silicon chip, as you all know. And more importantly, the back end is about 60 miles of wiring on a monolithic SoC, a state-of-the-art monolithic SoC today. And we enable a lot of that. But why I'm talking about this is when we move to packaging, and advanced packaging becomes a very critical enabler for everything we are talking about now, which is the chiplets and the heterogeneous integration, this wiring, which will now have to happen on the package, is going to become even more important. Then we all know, analysts have been predicting, and we do definitely see the trajectory to get to $1 trillion. It took almost 40 years to get to the first 500 billion, and now we're talking about getting to $1 trillion in the next 7 years. There's a lot of things that have to happen to enable this and to make this happen. So we are geared up to enable the industry, to all of you, to enable all of your innovations, and to support that in terms of architectures, the 3D structures for the front end, and the packaging, of course, new materials, new ways to shrink, and the advanced packaging, of course, is going to become a very critical piece. This was already predicted almost 60 years back, as you all know, that the monolithic silicon will continue to scale, but at some point, chiplets will come into existence. This was already very clear. And that's really what is happening today, and which is why we're all here trying to find solutions and filling the gaps across from systems to materials. Everything needs to be taken care because the optimization is going to be critical, looking at it from systems all the way down to the materials. So we are, as a company, very focused on the system to material co-optimization. And on the right side, what you see there is the system level innovation. So Applied Materials, of course, we are an equipment company, but like I said, we have to enable innovations and stay ahead of the semiconductor technologies. So we have invested in system design to system architects so that we can bring together a system view and connect it to the materials and the material innovation. Okay? So as an example, the power efficiency is going to become critical, even more critical as we continue to scale, and we know that. So we have some interesting innovation that we're going to bring to the ecosystem to ensure that there is going to be power efficiency and to continue to scale. As to say this in terms of overview, if you look at all the way from the systems at the top, all the way to the bottom, which is the materials, we have to be looking at optimizing at every step, at every stage, at every angle, because if you want to get the full benefit of the chiplets, the full benefit of the heterogeneous integration, we cannot leave anything on the table. Performance, power, area, cost, and of course, the time to market. If you had all the time in the world to take the chiplets to market, that's one thing, but nobody does. So the time to market focus is also going to be very, very important. So what we do is, if you look at where heterogeneous integration is today, we all know that this is really needed to continue to scale the Moore's law. But the Moore's law, the new metric, of course, is like cost per function and not necessarily cost per transistor. It doesn't matter how we get there, and that's why the heterogeneous and the chiplet is going to be very important. But the more important thing is to be able to enable the entire ecosystem with all the right tools, all the right pieces, and fill the gaps, so this can become a plug-and-play solution at some point. Of course, we are still a long way there. There's standards that are needed for database exchange. There are standards for the interconnect protocols. There's many, many pieces. All that is happening, and we do see a lot of momentum. I heard today that OCP attendance today or registration is 4,500 this time, and that's really amazing. So it's growing. So we're all coming together to make this happen, and we want to contribute to the ecosystem in terms of three things. One is, like I said, the system technology co-optimization, because we do bring a lot of material innovation and the equipment innovation, which are going to be fundamental to enable the chiplets and the heterogeneous integration. That's number one. Number two is to prototype and to check out all of the chiplet integration, the new failure mechanisms. There are going to be new issues, new problems, and new DFTs that may be required, new inspections, new metrology. Some of those things are going to become really critical, because we're going to be taking, or the entire industry is going to be taking, a system-level view of the chiplets and the heterogeneous integration going forward. And there are some opportunities out there, but more than opportunities, it's a necessity when it comes to the gaps that exist or will exist in the near future in terms of inspection and metrology and so on and so forth. The other important thing is, anybody who's going to go commit the company from monolithic to heterogeneous integration or chiplets will need a proof point to ensure this is the right thing to do. So in terms of the advanced packaging, the platform, the materials, the warpages, the mechanical issues, the signal integrity, the power integrity, all that needs to be checked and verified and confirmed and calibrated before they can make a commitment. So we are working on some kind of a test chip that can actually become a platform that can be reusable and optimized for any workload, optimized for a specific application, whether it's HPC or auto platform or communication, those kind of things, where you can clearly do that in a couple of months versus, starting from scratch, it may take 2 years. We call it the RPV, the Rapid Prototype Vehicle. So that's the second contribution to the ecosystem. Other than that, we acquired a company called Think Silicon, which has the ultra-low power graphics GPU. In fact, the watch that I'm wearing here, Garmin, has that ultra-low power GPU IP in it. So you may be surprised what is Applied Materials doing in some of these things. But the goal is to enable the ecosystem for heterogeneous integration and chiplets. We're also members of UCI and, of course, OCP. And I just want to give a quick overview and introduction. I don't want to bore you today with anything. If anybody has any more questions or interest, I'll be around. You can always contact us, and we'll give you more information. So I don't want to take too much of your time. Please enjoy the evening reception, and thank you for being here.